Welcome to Focal Points. This is Hot Zone, and boy, is it hot. I'm here with my investigative partner, John Leake. And John, welcome to the program.
Thank you, Doctor.
Boy, we named this a year or two ago, the Hot Zone, for two reasons. Can you explain to our audience, how did Hot Zone come up and why is it so relevant now?
Well, hot zone has two meanings. It's a hot zone and a military combat zone. We think of, for example, Vietnam, where the fabled UH-1 helicopters would drop down into an area that was contested by the Viet Cong. The guys would have to get off the aircraft, the chopper, oftentimes under heavy fire. That was called a hot combat zone. It was also, that military metaphor was adopted by a writer in, I believe, the year 1993, who wrote a book called The Hot Zone about specifically the Ebola virus. His contention was that we've come very close to Ebola outbreaks. It all started in the continent of Africa, but there was a famous example, I believe, in the 60s of the Marburg virus, which is closely related to the Ebola virus, getting out of a biosecurity lab in Marburg, Germany, hence the name. So hot zone being an area in which you have a highly infectious disease pathogen that has possibly spread to multiple people, and it presents a real challenge to investigators. What is the pathogenic agent? Who received it? How virulent is it? How transmissible is it? That's the hot zone in infectious disease parlance.
Well, we've got one right now in March of 2026, the hot zone in the United Kingdom. The organism is Neisseria meningitis, serotype B. That's meningitis type B. And let me just show this. We got a marker on the hot zone here, and that is Canterbury, United Kingdom. Give us a little backdrop about Canterbury and its relevance in history.
Canterbury is the principal town in terms of the British Isles becoming part of Christendom in the 5th century. There was a bishop who was sent to the back then the British Isles from Rome. I can't remember the Pope. Pope Gregory the First, I think, sent a Bishop Augustine to the British Isles to spread Christianity amongst the Britons. And he founded the seat of Christianity in Canterbury. It then became the seat of the Diocese of Britain, I guess, or at any rate, England. The fabled cathedral in Canterbury. Now, it's been the site of multiple dramatic events in British history, most famously in, I believe it was 1110 or 1170, the Archbishop of Canterbury, Thomas Becket, was assassinated in the cathedral.
What?
By some ruffians who came directly on the orders of Henry II, the British king, or the English king. And he felt like this, I think he called him this turbulent bishop is challenging royal authority by claiming that my royal authority, it has limits, ecclesiastical limits. The church and the state, or in this case, the monarchy, were oftentimes in a state of tension in the 12th century. And so he sent a couple of goons to kill Thomas Becket. Now, this completely shocks all of Christendom. I mean, this quickly reverberated throughout all of Europe. Word quickly got to Rome. And people thought, well, has the King of England just completely lost his mind? Canterbury then became the site of pilgrims. Thomas Becket was canonized as a Roman Catholic martyr, and it became a pilgrimage site where people from all over the kingdom would make a pilgrimage to Canterbury to pay their respects to this martyred saint. We know this from English literature. Geoffrey Chaucer's famous Canterbury Tales, written about 200 years later in the 13th century, kind of an early classic of English literature. Sometimes not all that easy to read. The English language has changed quite a bit since then, but at least in my day, and I'm an old man, we still read the Canterbury Tales as part of canonical English literature.
Sure, I remember the Canterbury Tales, and I never thought it would be, in the sites of news agencies as we depict here.
A Canterbury Tale.
Yeah, there it is. It's a Canterbury Tale that, at least for two individuals, has been disastrous at the University of Kent. So let me bring up another image, which is important, and that is gonna bring up just another image, and that is what we're talking about today, and that deals with meningitis. So out on Focal Points today, I have a status update. John's had several important posts in the last, few days or so, actually the last 72 hours. But we have a situation that's been evolving since around March 5th to March 7th, John. And why don't you take us to the scene of the crime, if you will, where we think it started?
Well, my understanding, based on UK Health Authority reports that were disseminated to the media, was the hot zone of this thing is thought to be a nightclub about 1.5 miles from the University of Kent. Apparently, it's popular amongst university students. I think it's called the Chemistry Club. It kind of looks like one of these infernal nightclubs where it's dark and bright strobe lights and loud music, and young, rambunctious people probably getting very close. I don't know this as a fact. I'm speculating, but oftentimes such nightclubs are rife with the use of MDMA. It's a kind of euphoric, psychotropic medication that causes an enormous dopamine rush, causing young people to lose all inhibitions and suddenly discover that they're all profoundly in love with each other, even though they probably wouldn't even talk to each other the next day when the dopamine crash sets in and they're hungover. But anyway, they have a fleeting feeling of enormous love and conviviality. Cocaine is oftentimes used in such nightclubs. I hope I'm not defaming the club. I'm speaking British nightclubs in general. I can't.
Of which, John, you frequented yourself, I understand.
Yes,
in yesteryear.
I was never a cocaine or an MDMA user, but I had a girlfriend in London who was something of a fan of nightclubs, and I remember witnessing this firsthand. Now, of note, we oftentimes talk about pharmaceuticals. I have a book here. It's a cultural and just a history of cocaine, really one of the most fascinating pharmaceuticals. Merck, the famous German pharmaceutical company that began as a family pharmacy in Darmstadt, Germany in the 17th century. By the time you get to the 19th century, Merck has become a huge multinational corporation, and their first blockbuster drug was cocaine. Pharmaceutical grade cocaine. They continued making in fact, I think they still do make pharmaceutical grade cocaine for very, very limited uses. I remember reading actually it's in the book. It's an interview with Keith Richards, the legendary guitarist of the Rolling Stone, saying that in the early days of the Stones, when they were doing these really grueling tours, Keith felt like what kept him alive, kept him going, nights of poor sleep on the road, was Merck cocaine. Absolutely pure,
Well,
unadulterated.
I've used that myself, John, with patients. It's available in a liquid form, and we actually just dip a little swab into it. And if you put it up the nose, it's probably one of the most powerful vasoconstrictors. You can stop a bloody nose very quickly with liquid cocaine, and that's probably what he had.
Apparently, the thing about Merck is that the purity of it, of Merck cocaine, just set it up. I mean, for these rock stars, just set it apart from any stuff that you would find on the street,
Right.
which is invariably heavily adulterated. And that's another piece. If my intuition is correct, that cocaine snorting, not necessarily in this case, but in general, could be a vector or call it a cofactor in meningitis amongst young people call it university students, then there's an adulterating agent in cocaine that could be another contributing factor.
Right, and that's levamisole. It's an anti-helminthic. It's actually used in cancer treatment as well, and rheumatologic diseases. Now, rarely it can drop the white blood cell count called agranulocytosis, which is more of an idiosyncratic reaction. Suffice it to say, it's immunoinhibitory. But John, let me zero in on this map for a minute, and I want to see if I can bring it into full view here. You can see that and I updated this today, that we have a total case count of 30 cases of meningitis, and 20 are confirmed, 2 deaths, one of a Kent University student, a young male, and then one of basically a high school student. She wasn't even going to school at Kent. And then there were 26 hospitalized of these suspected and confirmed cases. And then the regions here are certainly in Canterbury, but also in London, and one up in Manchester. The London case had traveled to Canterbury. The Manchester case had been in Canterbury. And then there's actually one exported case over to France, an exchange student. But take a look here. We're talking about Neisseria meningitidis, which is actually resident in the back of the nose and throat in about 15% of healthy, young adults this age. So it's colonized there, and as theorized, a breakdown in the mucosal barrier. So it can be, being run down, for instance, a prior upper respiratory tract infection, potentially vaping, using cocaine. Of interest, there's a belt of meningitis in sub-Saharan Africa, and there the description is that is mainly due to a combination of dry, dusty, and hot weather, December through June, damages the nasal mucosa, allows the bacteria to invade. And this dry season climate and these winds are called the Harmattan winds in sub-Saharan Africa. These are very poor countries, probably poor nutrition and little or no health care. But that's really what we're talking about here. Is we're talking about an epicenter in Canterbury, Kent area at Club Chemistry, the nightclub, and then the kids falling ill with this syndrome of meningitis. So they have photophobia, bright lights hurt, the neck becomes stiff, headache, quickly becoming delusional, losing mental status, and then a rash actually develops. And hopefully we catch the cases before the rash. A fever greater than 38.0 Celsius, rapid diagnosis. There's a rapid PCR diagnostic test. There's actually an antigen-based cerebral spinal fluid test. Do a spinal tap. Should be able to quickly diagnose it and quickly treat it, with third-generation cephalosporin, ceftriaxone or cefotaxime. And then we actually use steroids, steroids, dexamethasone or methylprednisolone. So the syndrome can be treated, John. The issue at hand is the fact that this started to take off, and the UK Health Security Organization got behind on it somewhat, and there's a tremendous fear spreading across the United Kingdom. In fact, probably even Western Europe.
Yeah, I mean, the question is, how much of this is a media artifact? Just reviewing the literature on this, it would seem that in the epidemic year 24-25, there were 31 cases of death in the United Kingdom reported from this disease. Is this the question that investigators must now face? Is this just a dramatic cluster that has caught our attention because of the sort of hot zone of this nightclub that seems to have perhaps conditions that are making it an unusually virulent outbreak? But maybe could it be that this, if you go back to a 365-day period, maybe this will prove to be a dramatic but not necessarily outside of the annual norm? And what are your thoughts on that?
It's there have been, during this time period, there was a baby who was diagnosed, and the UK HSA has been quick to say, listen, the baby has nothing to do with the kids that trace back to the nightclub. So far, the cases we're talking about all trace back to Kent University, Canterbury, and or the nightclub. To me, what's impressive is that these are ostensibly well-nourished, healthy individuals. The two kids who died were healthy, and unlike this belt of meningitis that comes in, sweeps in every year in Africa, and the fact that it almost has a spread pattern that looks more contagious than usual. So it raises the issue: could the bacteria have mutated? Now, in these thousands and thousands of press releases, the vast majority quickly come to one conclusion: that this is a vaccination gap and that we need to vaccinate as the solution. And I think public health officials have figured out that, if there's a scare, it's a wonderful opportunity to promote vaccination, which they do. Now, the vaccine, the traditional meningitis vaccine that's on the UK schedule, does not cover serotype B, covers other serotypes. And the meningitis B serotype, that came into use and coverage in the public health system in 2015. So this is important to understand. Now parents could have their children vaccinated before they went off to University of Kent, but it would be private pay. It would cost probably a couple £100 to get a meningitis B vaccine. It's called Bexsero. Now, it's been out on social media that there was a purchase of Bexsero, a large purchase last fall, and people have conjectured, wait, were they getting ready for this? And the answer is no. We covered this on Focal Points. There was a large purchase of Bexsero in the UK because of a recent program to use off-label or off-target indication for Bexsero against another Neisseria organism, Neisseria gonorrhea. And so of those who had gonorrhea, they could actually get some protection from the Bexsero vaccine. That's the reason why it was purchased in large quantities. But nevertheless, the authorities have encouraged vaccination. Now remember, with the Bexsero vaccine, it's 2 doses. So there's dose 1, 30 days later there's dose 2, and then 2 weeks after that, immunity kind of shades in and begins. So a vaccination cannot be a solution, an immediate solution for an outbreak like this. The immediate solution, which I believe will bring this to an end, is the use of ciprofloxacin, which is an oral antibiotic. It's very effective in eradicating the organism from the nasopharynx. In fact, it just takes one dose, 500 to 750 milligrams. So they're passing out a lot of Cipro, which I think is wise. And, in an outbreak like this, it should be extinguished pretty quickly. The kids simply can't carry it after you've taken a dose of Cipro.
Yeah, I mean, thank goodness for antibiotics. You and I have had this conversation, you as a medical professional, the COVID-19 pandemic and the rather sorry job that so many physicians did resulted in a widespread loss of faith in the medical profession. You've oftentimes pointed out to me, yeah, but don't throw the baby out with the bathwater. There are good doctors can still pull your bacon out of the fire. And, I experienced this firsthand. At the beginning of the year, I was visiting my brother on Maui, and I contracted a case of cellulitis on the posterior part of my left leg. And boy, this rash was going, the characteristic red streaks of the lymph system being infected. I ran down to a ER here in my local town here in Dallas, and they got me onto IV drip antibiotics. And I was more or less fine and out of the woods the next day. So, we should always count our lucky stars for antibiotics in case we get too jaundiced about medicine.
Right. Now, behind me, over my shoulder, is the diplococci of meningitis. So the bacteria always travel in pairs, and they have little attachment proteins on the surface that attach to proteins in the cells in the back of our throat and nose. That's how they gain invasion. Now, our mucosal surfaces, we fight it off. And about 10 to 15% of young people carry this with them. They just carry it. And you and I could have been carriers. We don't know. We still could be. But the point is, we don't get sick with life-threatening meningitis until the bacteria invades. And so these attachment proteins have to lock on. They have to have a handshake with the host proteins in the membrane and then be able to invade. So it does raise the question, were there mutations in the circulating strains as vaccinations started in the UK in 2015? So widespread vaccination, that means all the babies and children now in the UK for about 10 years have gotten vaccinated. And now some of those children, it started in 2015, some of those children are 10 and 11 years old. Well, they're old enough to have brothers and sisters who are going to high school or university and could show up at club chemistry. So the question is, have the prevailing strains that have colonized the throats, could they actually now become resistant or are becoming somewhat resistant to the vaccine?
Yeah, this is the kind of the broad area of inquiry that the Belgian, mostly virologist, although I think he's generally trained in infectious disease medicine, Geert van den Bosche, has talked about this. You have a vaccine that is widely deployed. It doesn't induce complete coverage. It moreover may be a leaky vaccine, meaning it's not entirely sterilizing. You may have some immune protection from the vaccine, but the pathogen remains. It may be attenuated or less likely to invade, but you're still carrying it around. Could this mass vaccination be applying selective evolutionary pressure on the organism, causing it to evade the vaccine, so you get a possible rapid mutation of a particular strain against which at least some proportion of the population is not protected? There was a notable example of this that even National Geographic published a report on it in 2015. Marek's disease, which affects poultry, the discovery was that the problem with the Marek disease vaccine in poultry was that it was a leaky vaccine. It actually had the unintended consequence of making Marek's disease more virulent in poultry. It's almost like the vaccine equivalent of antibiotic resistant bacteria. There's a similar selective pressure being applied. Yeah, go ahead.
Well, and for sure, this is in this case, instead of Marburg's being a virus, this is a bacteria, right? And so bacteria, they're self-surface. That's the reason why there are serotypes. And with these are encapsulated organisms, and like the pneumococcus has just sprouted new cell surface proteins, and the pneumococcal vaccine keeps trying to cover more and more of these surface antigens, just like with meningitis. So let me just show you this image of what we're talking about here, and that is, all these students getting in line. And see if I can bring it forward. And the point I want to make, John, is notice that they're not wearing masks. They have not been told to wear masks. Well, there's a reason why. The virus is spread by large droplets. So you have to be kissing, sharing, a smoking pipe or a glass. Lots of oral interchange here. I guess you could, have a big wet cough or sneeze right in somebody's face and spread it, but it takes very close contact to spread it. So even those lining up for a vaccine or the ciprofloxacin prophylaxis are appropriately not wearing masks. And then there's the bacteria there, this diplococci. It's in the same family with gonorrhea. But one of the things, if it goes untreated, because it goes in the bloodstream, it's tremendously destructive, John, to blood flow. It can cause amputation because loss of limb and tissue destruction, and it can actually destroy the adrenal glands and cause a syndrome called the Waterhouse-Friderichsen syndrome of an adrenal crisis, adrenal insufficiency. So it's a very serious illness. And it doesn't necessarily occur in people systemically immunocompromised, but we're suspicious of a breach in the posterior nasopharynx, oropharynx, or potentially a mutation in these kind of little hairy projections in the bacteria itself that's enabled it. Now, fortunately, it looks like this is on the way down now, and hopefully we'll be coming to near the end of it. But people want to know what's going on. The conspiracy theorists. Oh, by the way, John, on social media, someone got on my post and said, "Aha! There's no such thing as meningitis. This bacteria has never been isolated. It's a hoax like COVID." So believe me, the virus deniers have absolutely no compunction. They will deny bacteria as well. So those people
funny.
do exist out there. They're under rocks somewhere.
Well, I mean, the one thing that and we talked about earlier, my first thought was, is there a lab in the United Kingdom that has been tinkering around with this bacteria as part of some kind of new vaccine program? For our audience that is unfamiliar with some of the ways you test a new vaccine, it's called challenge studies. You take an animal, it could be a rat, or it could be a primate like a rhesus monkey. You're trying to test a new vaccine against a new serotype or a new mutation. Now, the one thing people have to bear in mind is that our biopharmaceutical complex has gotten into the business of not only cataloging existing pathogens, but also with this, in my opinion, logically fallacious enterprise of, well, let's try and predict how some of the existing pathogens might naturally evolve and mutate, let's go ahead in the lab and through serial passage or other gain of function techniques, let's go ahead and create mutated iterations of these pathogens. And then we can try and get ahead of it by developing vaccines that are not only useful against existing pathogens, but against theoretical pathogens that we are actually going to create in the lab. So I wondered, is there a laboratory in the United Kingdom that has been tinkering around with this pathogen in order to do vaccine challenge studies? And I mean, we initially talked about, could this bug that seems to be particularly virulent, could it have gotten out of a lab? And there was a student in the greater Manchester area. Manchester happens to be the site of a meningococcal pathogen lab. It's kind of looking like the totality of circumstances would suggest that's not the case, but I still think, given the tendency of our public health authorities to not be entirely transparent, we can't really rely on our authorities to tell us the whole truth and nothing but. So, I mean, I do kind of wonder. I mean, you mentioned the meningitis belt in Africa. I mean, good grief. I mean, one would think that if there's some alarmingly virulent, outbreak, I would think a slum in Nairobi or Manila, the Philippines. It does seem kind of odd that this should emerge in Kent, England, amongst well-nourished college students.
Yeah, I concur. Now, we did a little research about this laboratory origins of things. So it turns out the Manchester lab is really in vitro diagnostics, John. They are not, working directly with the strains. There are some other places that are. So, for instance, University of Oxford, is working on a genetic vaccine. It's called the ChAdOx1 Men-B vaccine, replication deficient adenoviral vector. So now we're back to the same idea with the COVID vaccine. The genetic code for the meningitis B antigen or antigens, it loaded into a virus, and then that virus forces the human cells to produce that antigen. So that's going on. There is the Tang Lab, the Sir William Dunn School of Pathology at Oxford. It is focusing on molecular techniques. And then the Maiden Lab at University of Oxford, population biology and genomics. But this is the one that concerns me the most, and that's the Spencer Damon Meningitis Laboratories at the University of Bristol. You and I were in Bristol not too long ago. This facility stores and analyzes tens of thousands of samples to study meningococcal disease and carriage among UK students. There is the Vaccine Institute at St. George's in London, which conducts clinical trials, and then the Imperial College in London, which does outbreak investigation and analysis. So if I was to consider a potential source of a lab-derived pathogen, it would zero in on this Bristol lab. But the point is, listen, UK is loaded with expertise and technology in this area. And I think they have rapidly deployed. What's winning the day is the antibiotics, though. There's no doubt. There's no one's going to be saved here by a vaccine. I predict, though, that this outbreak will be the impetus for the UK to add the Bexsero meningitis B vaccine to the routine schedule as the kids enter high school or college, and watch for that to happen in the United States as well.
Yeah, I mean, what troubles me about, I always go back to a wonderful economist, Thomas Sowell, who is a controversial character because, in my opinion, he always tells the truth. The truth is controversial. And, he points out how the problem with so many institutions that are set up and funded purportedly to combat threats to whether they be economic or public health or military or whatever it is. The problem with these institutions is if they solve the problem, then they're out of business. I mean, it's like, well done, boys. We don't have a problem with meningitis anymore. Have fun doing something else, collecting beer cans or something. So it's like these guys kind of have to keep this going, or else they're out of business. And this is the big concern with these biolabs. I mean, since the Spanish influenza of 1918, we've just been constantly told in the West, where we have extremely high living standards, we're not undernourished anymore, which mankind was for most of its history. We're actually overnourished now. So it's like, but we have to maintain these biolabs, and we have to be tinkering around with these bugs all the time to create new vaccines and so forth. Because if you work in this complex, what are you to do if there really isn't a problem? So the question is, and I'm speaking in general terms about biosecurity labs and labs that tinker around with infectious disease pathogens, are those labs presenting a greater risk to public health because of the possibility of pathogen escape than nature, with its random evolutionary processes? Which is the greater risk? And I don't know, but if I were a gambling man, I'd put my money on the labs being the greater risk.
Well, we're going to hear this argument, I think, be played out with respect to this meningitis outbreak in the UK. Did nature, pitch us a virulent and highly contagious organism, and public health had to respond with heroic measures? Or was this something that potentially was lab manipulated? Now, genomics can help greatly, and we should, the nice thing about a bacteria is that it's pretty easy to really completely know what you're dealing with.
Yes, doctor, but I mean, that's trusting. Like, let's say this thing were to be a perfect match with a lab manipulated sample that has been used for challenge studies. And so that sample in a lab, you say, okay, we have a perfect match. And I think that the genomic guys can see, okay, this has been tinkered with. Can we rely on our public health authorities to tell us the truth? And I say no. I mean, they're still lying about Wuhan.
Right, they're still lying. But not only that, but Ralph Barrick, one of the co-creators of SARS-CoV-2, won't release his genetic code to his 2015, 2016 published virus. Now, it could be there's gain of function through serial passage, where you keep testing different strains of organisms until they can invade in a particular model. And then there's direct genetic manipulation of, in this case, probably cell surface proteins. But there's a third potential scenario, John. And I go back to that lab in Bristol and think about it. They have tens of thousands of samples. And, I'm sure they have samples of fatal cases. This is important. So let's say a baby by chance gets this and dies. It doesn't spread to anybody, but the pathogen is captured. So some of these samples must be very highly pathogenic strains. Now, they didn't go anywhere because there wasn't any spread, but they're in a lab. And if someone is tinkering around with that, there's a breach, or maybe these are organized by pathogenicity. In a sense, the lab itself, by the fact of cases where survivors and those who died, they have a range of strains some that are milder and some that are highly lethal.
Well, precisely. And then to make matters even more complicated, I could imagine a scenario, and you correct me if I'm wrong, maybe I'm just being overly imaginative. I could imagine a scenario where a sample gets out of the lab, it infects someone, but whoever it infects has a good immune system, a good nasal mucosa, so he's not getting sick with it. He then goes to club chemistry and shares some cocaine out of the same straw with a group. The cocaine, this is a hypothetical I want to.
Mm-hmm.
So he's a carrier of a pathogenic strain, but the genie doesn't get out of the bottle until you have an event in which there is a breach of the nasal mucosa, and now you're off to the races.
Oh, I get it. So the scenario could be just, let's say, a lab worker in the Bristol lab who is on a hot date with a girl at Kent University. And he goes over to Canterbury and they decide to go to club chemistry.
Let's party. So silent carrier,
there you go,
pathogenic strain, and then, right place, right time, party time.
Well, listen,
and you're off to the races.
The kid who got sick at the college in Manchester, it was initially reported to be an unrelated case, and then it was found out, well, he had just been to Kent before. You remember going to college and you visit your friends at other colleges, and England's a small place. I think Manchester to Kent is about 4 hours. Bristol, I think, is even closer, isn't it?
Yeah, Bristol is much closer. Bristol's probably an hour train ride, maybe.
Yeah. So this idea, there are labs with highly pathogenic strains. There clearly is asymptomatic carriage. Oh, and by the way, the vaccine is not sterilizing. This is very important. The vaccine is not. So, people are still allowed to carry the bacteria. What's sterilizing temporarily is to take a dose of ciprofloxacin. So, so here we go, John. I think we've covered it pretty well. I anticipate we're on the back side of this now. They're weeding through, any kid with a headache and fever right now is being considered a potential case, and then they go through the testing. But we're down to, I think, a solid 20 cases, and 2 kids die. That's a case fatality rate for confirmed cases of 10%, and that fits with the literature. It is a deadly disease.
Well, what can we learn from this? I guess, I'm sort of at a loss. It's a very disturbing event. Again, thank God for antibiotics. My prescription would be this needs to be thoroughly investigated. And if the public health authorities in England, if investigators are really doing their job, they should do careful genomic analysis to see if this matches anything in a laboratory that has been used for vaccine challenge experiments. Now, I did notice, we didn't cover this, there was a paper that was published in January of this year about a new meningococcal B vaccine. It was first deployed as an emergency use authorization at a nursery in England. That paper was just published. It's about a new vaccine, Tremenda, I believe it's called, that purportedly covers strains that are not covered by the existing vaccine, which has been used since 2015. I sent that paper to you. Do you have any thoughts about that? That vaccine is apparently being deployed now, by the way.
Well, it's an interesting thought because in children with the Bexsero vaccine, the original vaccine, the protection is estimated between 75 and 83%. It's not perfect. So there have been babies, despite the routine vaccinations, have gotten sick with a meningitis serotype B. So that's the impetus for the new vaccine, Tremenda. So is it possible that babies vaccinated with the new vaccine now have provided the culture media for a highly resistant strain to emerge, And all you have to do is, be a young person and be kissing babies and what have you, and get some close contact with some babies, and then there can be a teenage carrier. So that would be the theory there. So we need really, really tight contact tracing, not just who went to club chemistry and who didn't, but where is the source of this? So for everybody who got really sick, we should ask the question, were you kissing or hugging babies? Dating anybody from Bristol or anybody from the lab? There really should be investigation, John, to the source of this. There's a small enough number of cases where there can be really good contact tracing and investigation. And of course, as you mentioned, very good genomic testing to see what we're dealing with.
I guess the last thing, you being a career medical professional, some of our audience may not fully grasp what I think strikes people as sort of the paradox. And I remember when I was a boy, my pediatrician, we were talking about a staphylococcal infection. And I remember my pediatrician said, I think he said 10 to 15% of people carry staphylococcal bacteria in their nasal mucosa, and it just doesn't cause any problems. They just kind of walk around with it, and it's not a problem. Under certain circumstances, it can become pathogenic and create infected wounds and so forth. Can you maybe a more elemental elucidation? What does this mean that we carry bacteria that we think, that's a horror show infection, but it's not actually creating any pathogenesis? Can you explain that? And what does medicine say about this as a general concept?
Right. Well, we have very strong mucosal barriers. So the mucus in our nose and our throat, we have little hair cells that are constantly beating it, so it's flowing, so the bacteria can't set up an infection. We have antibodies in mucosal secretions called IgA that readily bind to these bacteria. Then we have white blood cells that kill them. So we have a wonderful mucosal barrier, and organisms are what we call commensal. They can live in our nasopharynx, and provided we let them live. So Staphylococcus in the nose is a good example, including methicillin-resistant staph. It's in the nose of about 25% of healthcare workers. So the classic example of a terrible infection is when a surgeon has an uncontrolled sneeze and some of the Staphylococcus come out and land right into a wound, let's say a sternal wound for cardiac surgery, and we get staphylococcal mediastinitis. That's a classic example. All of us harbor, John, for instance, Clostridium difficile in our GI tract called C. diff. All of us have it, and most of it is not a problem. But unless the microbiome in the gut really gets disordered, our immune systems go down, and then we can get Clostridium difficile enterocolitis, which can be a real nightmare in terms of a diarrheal syndrome. And so what we've learned here is that our body's natural immune systems are powerful, that there are certain interventions we can use to boost the immune system. I've been interested in nasal sprays and gargles as a way of just kind of knocking down some of this pathogen count in the nose and the mouth. This may have been a strategy that could be deployed here. And then, of course, do reasonable things. Sharing smoking and vaping devices, snorting through the same straw for cocaine, or snorting cocaine at all, for instance. These types of things are going to open up a pathway. Keep your hands out of your nose and mouth, for instance. That's a very good practice. But danger lurks within our bodies, John, all the time. And it's our immune systems and our immune mechanisms, like the nasopharyngeal flow and local microbiome, that save us on a day-to-day basis.
Yeah, this was the wonderful conversation we had with Dr. Is it Robert Clancy in Sydney?
Yeah, well, he has a wonderful line of work. He's nominated for the Nobel Prize. It's called the common immune system. So we have all these organisms in our nose and mouth, and we're always swallowing. By the way, we swallow well over a cup of secretions a day. and they go down into the GI tract where they interact with lymph nodes in the proximal small bowel. Those lymph nodes then send signals over to our lungs and our tracheobronchial tree to actually prevent pneumonia. He's demonstrated that, particularly for encapsulated organisms like the pneumococcus. So the depths and redundancy and the complexity of our immune system and the microbiome are still not fully understood, but it is a wondrous set of observations to make about how we exist every day with organisms that could, in certain circumstances, like meningococcus, that could kill us.
Right. Well, I'll conclude by just a general observation, just the value of taking, like, never mind, all of this fancy pharmaceutical stuff. I mean, just taking care of oneself, just having wholesome routines, eating wholesome food. I think the most important thing is sleep.
Yeah.
I noticed when I got my cellulitis, it was around New Year's. My brother and all his friends on Maui, I'd not seen them. We were having a raucous good time with New Year's, drinking too much alcohol. I wasn't getting enough sleep. And the other thing I've noticed with sleep, it almost strikes me as the kind of panacea. I have personally noticed my blood pressure will start trending up. But then if I really make an effort, like real discipline, like don't work late at night on the computer, go to sleep at the same hour every night, and I start getting regular sleep, that blood pressure comes right back down to normal. So, college kids, they like to party. They drink too much alcohol. They play around with recreational drugs. They don't get enough sleep. That although my advice is probably going to be wasted on them because young people think they're bulletproof. I certainly did. But anyway, wholesome habits, they go a long way.
They go a long way, and in this case, we've learned a lot. So, John, thank you so much for joining us on Focal Points. This will be out on Focal Points, and as well as an America Out Loud Talk News McCullough Report. We have covered the serotype B meningococcal outbreak in the United Kingdom, which we anticipate is coming to close. I'm Dr. Peter McCullough with John Leake, your host. Thanks for watching.